In this video, I'm going to introduce you to a new topic called motion diagrams. Now, in your secondary school, you may have learned about motion by studying graphs. Now, in this chapter, I'm going to show you something different, okay? Something called motion diagrams. Now, before we move on, let us just understand why studying motion is important. And the main reason is because motion helps us in our daily lives to get about our activities. Okay, for example, you take the MRT or bus to school, okay, and without the MRT or bus, you would probably have to walk for a very long time to get to school. Okay, and then airplanes, of course, help us to get between different countries over longer distances, and your goods arrive from other countries via aircraft and ships. So motion is a very important part of our lives, and of course it's very important for us to be able to understand what motion is all about. Okay, so one way of describing motions is what I'm going to introduce to you in this video using motion diagrams. Okay, so we will draw a motion diagram on the worksheet. Okay, one word is missing here. So okay, on a worksheet. Okay, and so what I'd like you to do is to go to question 2, page 19 of your worksheets. Okay, so what are motion diagrams all about? Okay, firstly, you need, you see that you have a graph paper here with all the squares, and then you need an axis, which is called the x-axis. This label x here, and you need to indicate where this is where your origin. Okay, this is my axis. Okay, and of course we need to state the scale of the graph paper. In this case, it's 1 box 1 meter. So this means that this distance is 1 meter. Yeah. Okay. All right. So that's the first thing. Before we have any motion diagram, we need to draw an axis and state where our origin is. Okay. Step 2. Now, how do we represent the location or position of the object which is moving? Yeah. Okay, so what happens is, firstly, you see that we draw a dot. Okay, this is a dot, and it tells us exactly where the object is. And in this case, you notice that, hey, here is the dot, right? So its locations are exactly from the origin. This is 0, this is 1, and this is 2. So the dot tells us that the object is at 2 meters. Yeah, x equals to 2 meters. That is its object's location. Okay, and you see a number above the dot. That tells you the time in seconds when the object has reached that particular location. So that tells you that, hey, okay, at this point in time, the time at which the object is at 2 meters is at 0 seconds. Okay? Right. So that's the purpose of the dot and the number. So just remember where the dot is the location, and the number above the dot is the time. Okay, and so what happens is that we can have more than one dot to represent the object's motion. So for example, the 1 second later, this is where the object is, and at time equals 2 seconds, this is where the object is. At time equals 3 seconds, that's where the object is. 4 seconds, 5 seconds, 6 seconds, 7 seconds. Okay? Yeah? Alright, so the dots will tell you where the object's location is. And for example, let's see, okay? At time equals to 3 seconds, 3 seconds, where is the object? Okay, so it's at 0, 1, 2, 3, 4, 5, 6, 7, 8. So if at time equals to 3 seconds, the object is at x equals to 8 meters. Okay, so that helps us to describe the location of an object at a particular point in time. Now, another word you may have heard of is velocity, which refers to how fast the position is changing. And what happens is, you'll notice the spacing between the dots, okay, is the same between successive seconds. So for example, 0 and 1 second is separated by 2 meters. 1 and 2 seconds, again separated by 2 meters. So that tells you that how fast the position is changing is that it is increasing by 2 meters every second. Or in other words, in this case, the velocity is equals to 2 meters per second. And since the spacing between the dots is constant, okay, that you can say that the velocity is constant. Okay, so that is the introduction of motion diagram. And so let's recap. first we need to specify our axis and our origin. Secondly, we represent the object's location by a dot, and the number above the dot tells us the time at which the object is at that particular location. Okay, and the several dots on the same motion diagram will tell you how exactly the object has moved. Okay, so imagine we drew only the dots. Why do you think this is a bad motion diagram? Okay, simply because you cannot tell the direction in which the object is moving. So I'll give you an example. Suppose the dots, the time went this way. 1, 0, 1, 2, 3, 4, 5, 6, 7. So that tells you that the object is moving to the right, yeah? Okay, and however, if the numbers above the dot, okay, let's change the color, were to go this way, yeah, let's choose a different number, okay, okay, let's choose a different number now, different color now. Now, if the numbers above the dot were the ones in green, that tells us that the object starts here at 0 seconds and moves here at 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, and 7 seconds. In other words, if the numbers were the ones in green, the object is moving to the left, yeah? So the numbers are important because it tells you the direction in which the object is moving. Okay, so how do you calculate velocity from the motion diagram? Very simple. What happens is that, okay, if you notice the easy way, okay, is to say, okay, from 0 to 1 seconds, it moves 2 squares, so the velocity is 2 meters per second, yeah? Okay, and we say to the right, okay, because the object can be moving to the left as well, okay? Or if you prefer to, or if you prefer to use a formula, you can use the formula later position minus earlier position divided by the time taken. So, okay, let's choose our positions now. For example, let's choose a position of 6. This is the later position because it occurs at a later time. This is my earlier position because it occurs at the earlier time. Okay, so let's count. So it's 2, 4, 6, 8, 10, 12, 14. So this is at x equals to 14. This is at earlier position, x equals to 10 meters. Okay. Alright, so later position 14 minus earlier position 10 meters. Okay, don't forget the units. Divide by the time taken. So time taken 6 seconds minus 4 seconds. Yeah, 6 seconds minus 4 seconds. Okay, so that is 4 divided by 2, 4 meters divided by 2 seconds equals to 2 meters per second. Okay, and that's it for questions 2 and 4 of your worksheet.